Hi everyone, Miss Sheehan here with the first video of Chapter 7. Now, my objectives for this particular video is to teach you how to write ions, because you can't write ionic compounds unless you know how to write ions first. So let me make this a little bigger so we can get started. So we need to know, what is a chemical formula? Well, there are two types of chemical formulas that we discuss in Chapter 7. The first one is molecular formulas, and they represent the numbers and kinds of atoms in a covalent molecule. You'll remember from Chapter 6 that covalent compounds are made from nonmetal atoms. We call those molecules. Formula units are a little bit different. They represent the smallest whole number ratio of ions in an ionic compound. Now, the ionic compounds build these big crystal lattices, and we can't write all of the ions that make up that crystal lattice, the cations and the anions. And so we look at the smallest whole number of the cations and the anions, and we call that a formula unit. So if you remember from chemistry class, I showed you the big model of sodium chloride. But the smallest whole number ratio of sodium and chlorine in sodium chloride is 1:1. So the formula unit for sodium chloride is NaCl. And we'll get to how to write these formulas in the second installment of my videos for Chapter 7. We need to understand that all formulas represent electrically neutral compounds. So even though an ion may be charged, when it pairs up with another ion of opposite charge, because of that electrical attraction, they cancel each other out, so the formula is neutral. So, ionic compounds. Definition. We already discussed this, so this should be something that you already know. But it is the electrical attraction between a cation and an anion. Metals lose electrons to form positive ions called cations. Nonmetals gain electrons to form negative ions called anions. So both metals and nonmetals want noble gas configuration, and that's why they form ions. And then your negatives and your positives attract each other, and you end up with an ionic compound. So, how do we determine those charges? Well, for most of the main group elements, and you'll remember that they're the S block and P block elements on your periodic table, the periodic table helps us know what kind of ions they will form based on their location. So you know that metals are going to lose electrons to form cations. Here's an example. All metals want to attain an octet. That's what's driving these atoms to form ions in the first place. So magnesium's electron configuration is 1s2, 2s2, 2p6, 3s2. It's got 2 valence electrons in its outer shell. Well, magnesium is going to lose those 2 electrons to become a +2 cation. When it loses those 2 electrons, it forms a +2 charge because there's 2 more protons in the nucleus than electrons in the electron cloud. So the net charge on the atom is +2, making it a cation. Something similar happens to nonmetals. Nonmetals gain enough electrons to form an octet. So oxygen, for instance, has an electron configuration of 1s2, 2s2, 2p4. So how many electrons does it need to gain in order to fill that p orbital? You're right, 2. So it takes on a -2 charge because electrons are negative, and we just added 2 additional electrons to the p orbital. Now there's 2 more electrons in the electron cloud than protons in the nucleus. Well, it's kind of cumbersome to keep writing these electron configurations to figure out how many electrons is it going to lose, how many electrons is it going to gain. So there's an easier way to do this. We can look at the periodic table and know which atoms have how many valence electrons. We know metals lose electrons and nonmetals gain electrons. So we can use the periodic table to figure it out. Transition metals and tin and lead, which are in column 14, they don't really follow the typical pattern, and we'll be discussing them in another video. So even though on the periodic table in the next slide there is the charges for those elements, we're not going to pay any attention to them at this point in time. We're just going to focus on the main group elements. So here's the periodic table with the charges at the top of each of the columns. As you notice, in yellow, the alkali metals, which have one valence electron, has a positive 1 charge. And the alkaline earth metals in the second column, which have 2 valence electrons, have a positive 2 charge. Now if we skip a few and go over to the boron family, starting with the first yellow block, which is aluminum. Aluminum is a metal. Boron is a metalloid. Not every atom on the periodic table tends to form ions. On this periodic table, if you look at the P block elements, the noble gases, which are at the end of the periodic table, are all in white. They do not form ions at all. And then there's some other white ones like boron and carbon that are not going to really form ions. They tend to form covalent molecules only. So the colored elements are the ones that form these ions most typically. So aluminum and all of the metals underneath it have 3 valence electrons, and so they will lose their 3 valence electrons. Again, in column 14, you got the 2 purple ones on the bottom. That's tin and lead, and we'll discuss that in the third video. This particular column where nitrogen is, nitrogen and phosphorus, those are your 5 valence electrons. They're in column 15. It's easier for the atoms to gain electrons at this point than to lose them. And these are your non-metal elements. Non-metals gain electrons. So the nitrogen family has a -3 charge, the oxygen family, -2 charge, and the halogens have a -1 charge. So using this chart and looking at your periodic tables, you should be able to know which charges the elements in those families take on when they form ions. So here's an example. Potassium ion. Well, potassium is in column 1. Potassium has 1 valence electron and therefore will have a +1 charge. So I want you to identify these next ions on your periodic table, write them down on a separate piece of paper so we can go over them in class. Magnesium, aluminum, sodium, barium, calcium. Write these cations in your notebooks. The next section is anions, and here's the example that I gave, nitrogen. The nitrogen ion has a -3 charge. So again, find these following non-metals on your periodic table and write their ions. We'll go over this in class when I see you next. Have a great night.